Hi guys, welcome to this video on integration by parts, one of the biggest components of this topic. This particular technique will help us integrate expressions that we haven't been able to integrate before. Now, like the product rule, essentially this is the reverse of the product rule. When we get an integral that is a product of two functions, and one function is not the derivative of the other, we're going to use this technique of integration by parts. So here is the rule in integration by parts. It's the integral of u dv, which is equal to uv take away the integral of v du. Say that a couple of times in your head or out loud just to reinforce what that rule is. And it has a specific way of writing it rather than the v dashes that we had with the product rule. So I'll indicate why this rule is the way it is. So if you can remember back in year 11 when we had a look at two functions, one being u, the other one being v, and we differentiated that, we ended up getting v u dash plus u v dash. I'll just write it in a slightly different way to the way we normally write it, which is v multiplied by du dx plus u times dv dx, which is the same thing. Now I'll just write. Now if we integrate everything with respect to x, so integrate this with respect to x, integrate this with respect to x, and also that with respect to x, what we end up getting, well, you can get rid of those dx's, top and bottom, and when you integrate a derivative, you're left with just the original expression. So then we have the integral of v du plus the integral of u dv, and then we want to just rearrange it so we end up getting the integral of u dv. So therefore the integral of u dv is equal to this, and then get that to the other side. So then we have uv take away the integral of v du. So integration by parts is the product rule in the reverse form, and then just rearrange that. So when you get the expression to integrate, choose u and dv in such a way to make the whole process fairly straightforward. So u should be something that makes the derivative quite easy, and dv should be the thing that you choose so that you can integrate. So, for example, you would not choose the log x to be dv because we can't integrate log x quite nicely. So that wouldn't be something to choose as dv. You might choose that as u. Alright, so now we can integrate x by itself and cos x by itself, but when you're multiplying them together, we can't just have a nice simple integration, so we use the product rule. So x is going to be the thing that we choose as u, and dv would be the cos x dx. So when you choose u as x, du dx is going to be equal to 1. Cross multiply, you get du is equal to dx. And choosing dv to be cos x dx, integrating cos x with respect to x, and we get positive sine. So this is u, this is dv. What we end up getting is uv, take away the integral of v du. Substitute your four expressions into that integration by parts rule. I do recommend and strongly advise that you write that each time. So u is x v is sine x, the integral of v du, so the integral of v du is that. And then we still have to integrate sine x. So integrating sine x, you get negative cos, double negative, you get positive sine, positive cos, and then don't forget your plus c. So if we differentiate our answer, you should get x cos x. So if y is equal to x sine x plus cos x plus an arbitrary constant, doesn't matter what that is, du dx is going to be, we will actually have to use the product rule right here, so that's u and that's v. So the product rule is v du, so v is sine x times the derivative of u, which is 1, plus x multiplied by the derivative of sine, which is positive cos, and differentiating cos, you get negative sine, and differentiating a constant, you get 0. So this and this go, so you end up getting x times cos x, which is the expression that we expected. Alright, our next one is the integral of log x. We haven't been able to do this before. We haven't been able to integrate the logarithm, and don't forget this is log with the base e of x, not with a different base, it's the natural logarithm. So what is the coefficient of log x? There's a 1 there. So there is actually a product of two things, but as it stands, it's quite difficult to recognize that 1. So we end up getting a 1 multiplied by log x dx. So if we choose u to be the thing that we can differentiate, we wouldn't choose log x to be dv because we can't integrate that. That's the question that we're actually doing right now. So choosing u to be log x, and then du dx is equal to 1 on x, cross multiply, and then we end up getting du is equal to 1 on x times dx. And then choosing dv to be 1 dx, integrating 1, what do you get? You get x. So v is equal to x. So now we're going to do uv, take away the integral of v du, substitute your four expressions, and we end up getting x log x, take away 1 dx. And we end up getting x log x, take away x, plus the constant. Differentiate that as an exercise, and you should be able to get log x. So that's quite interesting. So when we integrate the natural logarithm, ln x, or log with the base e of x, we end up getting x log x, take away x, plus a constant. So something that we haven't seen before, but you could be asked to differentiate in Extension 1 or even Mathematics. But now in the Extension 2 course, we can integrate the logarithm of x. Alright, we'll have a look at this question where we have limits. So it doesn't really matter which one we choose because we can differentiate both quite easily, but x might be a little bit easier than the exponential. So u equals x, du equals dx, dv equals e raised to the power of negative 7x dx. When you integrate that, you end up getting 1 on a, which is negative 1 on 7. So then, in this case, we're not going to get a plus c at the end because we have limits. So just make a big note of that. So we end up getting uv right here, uv, which is the product of those two. And then we end up getting take away the integral of v du. So that's why we end up getting that double negative, which is a plus. And then just substitute or simplify that first. We have to integrate that integral. So we end up getting 1 on 7. So there's a 1 on 7 outside of the integral of that exponential. So then you get that negative 1 on 7 again, hence why we get this negative 1 on 49. Sub in your 1 and sub in your 0. And leave your answer in exact form. Don't use your calculator unless the question says answer the integral to a certain number of decimal places or significant figures. So leave it in exact form every single time. Otherwise, the question will specify that. And here is a fairly nice question where you have to use a nice technique at the end. So whenever you get the exponential and either sine or cosine, this particular process happens every single time. Question starts off by the same thing. Start off by labeling your u and your dv. So u equals e to the x. Du dx is equal to e to the x. No surprises there. So du equals e to the x dx. So therefore our dv is cos x dx. So when you integrate cos x, you get sine x. So write in your uv, take away the integral of v du. Replace your expressions. And then what we get is e to the x sine x, take away, and then this is looking fairly similar to the question, the integral of e to the x sine x dx. So it's not incorrect, but we're going to use the integration by parts technique again. Now, if we call this u and this dv, we've already labelled u and v, so it might be nicer if we use different variables for the next step. So 2 letters I usually use is f and dg, f and g. So f and g will be used instead of u and v. Again, if you use u and v again, it's not incorrect, but you're labeling different things with the same letter. So you might want to use f and g. So again, for this particular part, and don't forget there's a negative outside of that whole thing. Okay, so just be careful here. So u equals e to the x, du equals the derivative, and then using sine x dx as dv, integrating sine x, you get negative cosine x. So this part stays the same. We have a negative outside of uv, or f and g, so the double negative turns into this. And then we end up getting take away. Remember, the negative's still outside that whole thing of, what was it? V, the integral of v du. So you've got these two. So that's why we've got this part here. Now that is the question. So the question is actually inside the answer. So if we get this and move it to the left-hand side, we end up getting 2 lots of the question. So 2 lots of the question is equal to this part right here. And then divide everything by 2, and then we end up getting what the answer is as stated. Now, there's no plus c until right at the end. Okay, so as soon as you have like integral signs, you don't have a plus c. As soon as you get your expression, you obviously need a constant, because when you differentiate a constant, you get 0. We insert the plus c in that step here. Ultimately, there should have been a plus c right here. When you divide by 2, you get a different constant, so there should be a plus c in the line above, which obviously is true right there. So there you have it. That's integration by parts. Learn the technique, learn the rule, because that pops up into various questions. And yeah, that's a big component of the integration unit. So I hope you like this video. Thanks for watching.